A common type of application problem in algebra class involves mixing two substances to create a third substance. I like to consider two types of mixture problems. We could be mixing discrete or separate objects, or we could be mixing continuous substances like liquids. We will see that there are some similarities between these two types of problems, but there are some differences as well. In discrete mixture problems, we are mixing separate, disconnected objects. Some examples are coffee beans, maybe mixing two flavors or two different roasts. Candy mixtures, perhaps different flavors of jelly beans, or perhaps two types of candy. Nuts, we might make a pecan and cashew mixture, as we'll see in a future problem. Birdseed is often made from mixing two or more different types of seed. We often have problems in which someone has sold a number of tickets, adult or child admission tickets maybe, at different prices, but has mingled the money from the two. We can use algebra to determine how many tickets of each type were sold. Similarly, in college, students often take a mixture of 3-credit and 4-credit courses. Of course, problems involving money are common in math courses. If we know there's a mixture of nickels and dimes adding to a certain amount, and we know the total number of coins, we can use algebra to determine how many coins of each type are present. This list is by no means exhaustive, but it gives us a good idea of the variety of discrete mixture problems you may encounter. Similarly, we can think about a variety of examples of continuous mixture problems. In these problems, the substances being mixed are like liquids and do not consist of separate individuals. Often in these examples, we actually have substances dissolved in liquids. In paint pigments, for example, varying shades of red and pink can be produced by mixing different amounts or percentages of red pigment in white paint. Different vinegars contain differing percentages of acid. Distilled white vinegar purchased at a supermarket generally has a 5% acidity level, while a high-quality culinary vinegar may have a 12% acidity level. Similarly, acid solutions used in laboratories are often mixed to produce a desired concentration level. Saline solutions and sugar solutions are similar. Alcohol solutions of different concentrations may be mixed to produce a needed concentration. The octane rating on gasoline indicates the percent of pure octane present in the gasoline. When gasoline is delivered to gas stations, it's often the case that only 2 grades of gasoline are delivered, and the third medium grade is produced by the pump, mixing the other 2 grades. The SPF, or sun protection factor, of sunscreens is similar. You can mix a high SPF sunscreen with a low SPF sunscreen to produce a medium coverage sunscreen. Radiator fluid is a mixture of antifreeze and water. Under different conditions, automobiles need higher or lower percentages of antifreeze mixtures in their radiators. Finally, types of milk are identified by the percentage of butterfat present in them. To produce low-fat milk, all the fat is removed or skimmed from whole milk. Then whole milk is mixed with the skim milk to produce the desired type of milk. Every mixture problem has the same structure. There are a variety of known and unknown values, but there are three quantities or amounts involved in the problem. These are the quantity of the first substance, the quantity of the second substance, and the quantity or amount of the final mixture. Similarly, there are three value numbers. The value numbers may be price or percentages, but they measure the essence of concern in the problem. There is a value number associated with each substance. In the case of the final mixture, there might be an associated number given, for example, the price per pound of the mixture, or a total value of the mixture. To set up a mixture problem, I use two equations. A quantity equation that has the form quantity 1 plus quantity 2 equals a final quantity, and a value equation that has the form value 1 times quantity 1 plus value 2 times quantity 2 equals the final value times the final quantity. Or it may have the total value given in place of the final value times the final quantity. Let's first consider an example of a discrete mixture problem. If pecans sell for $4 per pound and cashews sell for $6 per pound, how many pounds of each should be mixed to produce a 16-pound nut mixture selling for $4.50 per pound? We want to find the amount of pecans and the amount of cashews to mix. I like to clearly delineate the start of the solution. I'll let X be the amount of pecans needed and let Y be the amount of cashews needed for the desired mixture. The quantity equation is X plus Y equals 16. The value in this problem is money, so the value equation is 4x plus 6y equals 4.5 times 16. This equation represents the revenue from the pecans plus the revenue from the cashews equaling the revenue from the mixture. Now we'll use the two equations. First, we'll rewrite the first equation as x equals 16 minus y, and we'll substitute that into the second equation. This gives 4 times 16 minus y plus 6y equals 72. We then distribute the 4, collect like terms, subtract 64 from both sides, and divide by 2 to get that y equals 4. Therefore, we should mix x equal 12 pounds of pecans with y equals 4 pounds of cashews to produce the desired mixture. Let's also consider a continuous mixture problem in which we want to mix cleaner A with a 12% alcohol content and cleaner B with 30% alcohol content to produce 90 ounces of a cleaner that is 20% alcohol. In this solution, we are assuming this mixture is safe to make. In general, we should use extreme caution when physically mixing cleaning chemicals. Again, we'll explicitly identify our variables by letting X be the number of ounces of cleaner A needed and letting Y be the number of ounces of cleaner B. The quantity equation is X plus Y equal 90. The item of value or concern in this problem is the alcohol content. So the value equation is 12% of X plus 30% of Y equals 20% of 90. Remember that we must always convert percentages to decimals in calculations. Again, we will rewrite the quantity equation as X equal 90 minus Y, and also rewrite the value equation multiplied by 100 for the convenience of eliminating decimals. First, let's simplify 20 times 90 as 1800. Then substitute 90 minus Y for X. Distribute the 12. Collect like terms. Subtract 1,080 from both sides. And divide by 18 to get that Y equal 40. Therefore, we need to mix X equal 50 ounces of cleaner A with Y equal 40 ounces of cleaner B. Note that we used the fact that X was 90 minus Y to get that X is 50 ounces of cleaner A.